Welcome. We are in Unit 9, Solving Inequalities, and today we are at Day 2, Inequalities Involving Absolute Value. This is Section 1.6 from the book, and we look at Objective 2, Solving Inequalities Involving Absolute Value. There are two basic forms that these kinds of inequalities will take. Things where the absolute value is less than a number, or things where the absolute value is greater than a number. So we will look at these two different forms and see what we can find out. For example, inequalities of the form absolute value of x is less than a. So consider the inequality absolute value of x is less than 5. Well, think about this really what it means for a second. If x is positive, then it has to be a pretty small positive, somewhere between 0 and 5. And if it's negative, it's also kind of a small negative. It can't be too low. So in terms of the number line, I have 0, 5, negative 5. My number has to be somewhere in between the negative 5 and the positive 5. Since it's a strict inequality, I get the parentheses on both sides here. So the solution set is this open interval from negative 5 to 5. Look what's important here. I can write this as a compound inequality. Negative 5 less than x less than 5. And this is the important point about inequalities of this form. Whenever I have an expression absolute value of something is less than a number, I can drop off the absolute values and put the expression in the middle, and then plus or minus the number part on both sides. Now, the same idea works also if it's a weak inequality. For example, absolute x is less than or equal to 5. The first thing I'm going to do is write x in the middle, and then 5 and negative 5 on both sides. And that's my solution. Or if you want to graph it out on the number line, negative 5, 5, and they get brackets, shade the area in between, or as an interval, negative 5, comma 5, using brackets. All right, let's look at some more interesting examples. Solve the absolute value of 4x minus 8 is less than 10. So 4x minus 8, I drop the absolute values, it goes in the middle, and on either side I put the positive and the negative parts of the number. So 10 goes on the right, negative 10 goes on the left. And now I just solve the inequality. So I want to get x by itself in the middle, so maybe I'll add 8 to all three parts. So negative 2 less than 4x less than 18. Then I need to divide everything through by 4. Now, dividing by 4 does not change the sign because 4 is positive, so I get negative 1/2 strictly less than x, strictly less than 9/2. All right, and that's good for a solution, and if you want to draw it on your number line, you could, or write it as an interval, you could too, but this is where we'll stop for us. We'll say that solves the problem. How about this one? Absolute value of 7 minus x plus 2 is less than or equal to 4. Well, it's not quite in the form that I want yet. What I really want is absolute value on one side and a number on the other. So before I even do any real work, I need to subtract 2 from both sides. So how about absolute value of 7 minus x is less than or equal to 2. There I've subtracted 2 from both sides. Now, it's in the form that I want, absolute value of something less than or equal to a number. 7 minus x goes in the middle, less than or equal to on the right. I'll put the negative 2 on the left. And let's subtract 7 from everything. So subtracting 7 gives me negative 9 less than or equal to negative x less than or equal to negative 5. Now, I really want to see x in the middle, not negative x. So I could turn that into an x by multiplying by negative 1. So let's multiply everything through by negative 1. Of course, be careful, when you multiply by negative 1, that reverses the inequalities. So now the order is a little bit weird. The biggest number is on the left. 9 is greater than or equal to x is greater than or equal to 5. So the solution as an interval would still be 5, 9, with the smaller number on the left. Example 3. Oh boy. Okay, let's see what we can do here. First, notice that the absolute value on the right doesn't really mean anything. It's just there to confuse you because it's the absolute value of a number. You can figure out what that is. Absolute value of -2 is just simply 2. So take out that absolute value and just replace it with the number 2. Then let's drop absolute values and put the 2 and -2 on either side. What should I do next? Well, at this point, I will add 9/2 to all parts. So on the right, this becomes 2 plus 9/2. On the left, it looks like 9/2 minus 2. Now, to do that simplification, I need to change the 2 so that it has a denominator of 2. So instead of 2, let's call that 4/2. And on the right, instead of 2, we'll call that 4/2. And now we can see how to add those fractions nicely. So on the left, I have 5/2. And on the right, we have 13/2. Now, multiply everything through by 3. All right, I'm getting closer. I'm still searching for this x. I'm trying to get x by itself in the middle. It looks like I'll need to subtract 1 from all parts, and then I'll need to divide by 2. Okay, let's subtract 1. Now, subtracting 1 is like subtracting 2/2. So from the left, that ends up with 13/2. And on the right, by subtracting 2/2, I get 37/2 with a 2x in the middle. All right, last step, let's divide all parts by 2. Now, dividing by 2, maybe another way of thinking about it is multiplying by 1/2, right? That way, maybe I can see a little bit better how to do the calculation. 1/2, 1/2, 1/2. And so we end up with 13/4 is less than x is less than 37/4. All right, so it's not pretty, but we got there. We got the solution to this problem. Let's look at inequalities of the opposite form. Absolute value of something is greater than a number. So let's think about solving absolute value of x is greater than 5. So x needs to be really big positive or really low negative. In terms of the number line, if I have -5 and 5, the things that work will be strictly greater than 5 or strictly less than a -5. And the word or is important. I have two different parts of this number line, so it can be one part or the other. We might write this as two intervals, -infinity up to -5, and 5 up to positive infinity. And here's the key. I'm going to put the union symbol. It kind of looks like a capital U. It's not quite a capital U, but it's the union symbol that means or, and it means one set or the other. Bring the two of them together. Really, what I'm saying is two different inequalities. X is less than -5, or x is greater than 5. So this is the step I take whenever I run across inequalities of this form. And similarly, if I have greater than or equal, we just put the or equal part in there too. So if x is greater than or equal to 5, this tells me that x is less than or equal to -5, or, and it's important to put the word or in there, x is greater than or equal to 5. All right, let's look at some more interesting problems. Solve. Absolute value of 4x is greater than or equal to 12. So I really need two different inequalities. Unfortunately, in this form, I can't just put them both together. I need to solve two different things. So one is 4x, and I'll switch the inequality, less than or equal to, and I make that negative, -12. So that's one thing to solve. Or 4x is greater than or equal to 12. And we just have to solve these independently. So in the first case, divide by 4, I get x less than or equal to -3. Very good. In the second case, divide by 4, x greater than or equal to 3. So there we go. X is less than or equal to -3, or x is greater than or equal to -3. So we would shade this on the number line by putting a -3 and a +3, putting a bracket and shading to the left, put down a bracket and shade to the right. As an interval, this solution looks like -infinity up to -3 with a bracket, union, bracket 3 up to +infinity. Example 2. Let's solve 1 less than or equal to the absolute value of 4 minus x. And pause for a second. Is this example in the right form? Because I have a less than or equal to. Well, it is, but maybe one thing I'll do before solving this is just to swap the two sides of the inequality, just so it looks more like the form I'm working with. So when I swap them, I get the absolute value 4 minus x is greater than or equal to 1. And now I can see, yes, it's in that form that I want. All right, I'll drop the absolute values and it turns it into 4 minus x is less than or equal to -1, or 4 minus x is greater than or equal to 1. All right, subtract 4 from both sides. -x less than or equal to -5. Let's keep on going with this one. Multiply both sides by -1, x, 5, and I switch the inequality. On the right, subtract 4 from both sides. -x greater than or equal to -3. Multiply both sides by -1. X is less than or equal to 3. Oh, okay. So x is less than 3, or x is greater than or equal to 5. So on the number line, something like 3 there and a 5 there. Okay, last example. Solve 6 plus the absolute value of 6x minus 2 over 3 is greater than 10. So this is of the right form, well, almost. I'll need to subtract 6 from both sides first. So I get 6x minus 2 over 3, that absolute value. Upon subtracting 6, I get greater than 4. Okay, now I can drop the absolute value and turn it into two problems. 6x minus 2 all over 3 is less than -4, so I switch the inequality and I make it negative. Or 6x minus 2 over 3 is greater than 4. All right, looking at the first one, let's multiply both sides by 3. 6x minus 2 is less than -12. And then I'll add 2 to both sides. 6x less than -10. And then divide both sides by 6. X is less than -10 sixths. Oh, and -10 sixths, that reduces a little bit. That becomes -5 thirds. Or, now what do I have on the right? Multiply both sides by 3. 6x minus 2 is greater than 12. Add 2 to both sides. 6x is greater than 14. Divide both sides by 6. X is greater than 14 over 6. And 14 over 6 reduces a little bit. That becomes 7 thirds. So there we go. X is less than -5 thirds, or x is greater than 7 thirds. And those are the two big ideas, these two different forms that absolute values can take. So look for the forms, make sure that you put your problem into that particular form, and then you can break it apart. In the first case, we can turn it into just one string of inequalities. But in the second case, unfortunately, we do need to break it into two parts. All right, and that's where I will end.